All right, so there is a relationship between fractions and decimals and money and percents. So if I say, if I say I have 25 cents and I write it that way, that's the same as $0.25, right? And so what do we call 25 cents though? If there's a coin that represents 25 cents, what do we call that?
Quarter.
A quarter. And the reason for that is, take a guess. So this is 25 cents right here. Well, it's a quarter of a dollar. So if you look at this,
So it'd be half.
Yeah, so if you look at this, this is like 1/4 of the way over to this, right? So if you think of this as like a fraction, how much is shaded? Well, 1/4.
Oh,
1/4, right? So that's why they call it a quarter. It's 1/4 of a dollar. Okay. So as a fraction, that's 1/4. We'll circle back to that in a second. If I think of it as a decimal, it's literally 0.25, right? So this would be 0.25 here, which is basically the same thing. But 0.25 is the same as 25 over, if you remember your decimals, this is the tenths place, 1/10, and this is 1/100. So 0.25 is the same as 25 100ths. And 25 out of 100 is 25%, right? So per literally means cent. Cent means 100. Let's write that up here. Well, I'll write it over here. Cent. How many years are in a century?
100.
How many cents are in a dollar? How many cents? Like cents, like this. How many cents are in $1?
4.
No. How much is a penny? How many pennies?
Oh, 100.
Yeah, so a penny's worth 1 cent.
Oh.
Right?
Oh, okay.
So cent literally means 100.
Oh.
Okay.
It's literally asking.
Yeah, it's literally saying it's 100. So now let's try to do that with this. Okay. So when I convert 50%, that's literally 50 over 100 for the fraction. Now we can reduce that. So when it comes to reducing fractions, and I want you to write all this down. Reducing fractions, you do a thing called prime factorization, and you take prime numbers. Those are those fancy numbers that are divisible by 1 and only themselves. And you just start dividing the fractions. So I see that 50 over 100 can be divided by 5. So I'm going to say, and divide 5 on the top and divide by 5 on the bottom. 50 divided by 5 on the top is equal to 10. 100 divided by 5 is equal to 20. Now, I look at that and I know that 10 divided by 20, 10 is literally 1/2 of 20. So this reduces to 1/2. Okay. So this is our fraction, 1/2. For money, it's 50 cents, right? And that's the same for the decimal, it's 0.50. Yeah, it's exactly 50. Now, if we were to do this with this kind of thing here, like we were doing up above, this would be 0, this would be 100, or $1, depending on how you look at it. 50 cents would be 1/2, or 50% would be 1/2. Right? So what's 0.75 as a percent? Well, that's just 75%. And for money, it's just that's 75 cents. Now, as a fraction, we do that same thing we did before. We're going to say 75 over 100. And I'm going to divide the top by 5. And I'm going to divide the bottom by 5. 75 divided by 5. I think it's 15. And then 20 is 100 divided by 5. Now look at 15 and 20. Can those both be divided by 5?
Yeah.
So we just do it again. So that's why it's called prime factorization. We just keep dividing by prime numbers until we can't divide anymore. What's 15 divided by 5?
Is it 3?
Yeah. And then 20 divided by 5 is 4. So that's the fraction. One third, we'll come back to 1/3 in a second. That one's going to be not as much fun. All right, but let me do 25. 25 is just 0.25 as a decimal, 25 cents. 25 cents is literally 25 over 100. And I did that as my example. What did we say that was as a fraction?
I don't think
We did. I probably went too fast. We weren't able to write it down. As a fraction, what did I say it was? See?
Oh, 1 over 4. I don't remember you writing that.
Yeah. Well, we'll write it down here. So this was 1
Oh,
over.
wait. Where did you get 1 over 4 from?
Okay, let's go over it again. If I do this prime factorization, what's 25 divided by 5?
5.
Mm-hmm. So that's 5. What's 100 divided by 5?
20.
Mm-hmm. But are 5 and 20 divisible by 5?
Yeah.
Okay. So what's 5 divided by 5?
1.
And what's 20 divided by 5?
4.
Here it is.
I see.
Okay, good job. 1/3 is not fun because to get the decimal, sometimes you'll get a number. You basically have to take the numerator and divide it by the denominator. But I'm going to move that over here because we're going to need a little bit of space. So I'm going to say 1 and write tiny because we're going to need a lot of space. Well, 1.00 is the same as 1 because 3 doesn't go into 1. I've got to put a decimal here and think, well, does 3 go into 10? Yes, 3 times. 3 times 3 is 9. No. And then, so what's 9 subtracted from 10? 1. So now I'm going to bring the 0 down. When I bring the 0 down, guess what? I've got 10 again. So how many times does 3 go into 10? 3. What's 3 times 3?
9.
Mm-hmm. And I subtract 9. What's 10 minus 9? 1. And I drop this down. Now, guess what's going to happen? Every time I'm going to put a 3, every time I'm going to drop down another 0. So this repeats forever. So 1 over 3 is, well, it's not approximately. actually equals it. 1 over 3 as a decimal actually equals 0.3 repeating. The pattern just repeats. So as a decimal, we would say 33 repeating. Now I did that on purpose that way because for money, we're just going to say it's 33 cents. And as a percentage, we're going to say 33.3 repeating percent. You're not real happy on that one, huh? Well, let's do problem number 5 is similar. So let's look at that. It says, why do stores not advertise 2/3 off sales? So this is a percentage off, right? So we want to know, what is the percentage? What is 2/3 as a percentage? Well, to do that, we need to convert it to a decimal. So to convert it to a decimal, I'm going to say 2 divided by 3. But I'm going to draw this really big line. If I go too fast, say, well, slow down, you're going too fast. Okay? So now watch this. Does 2 divide evenly into, does 3 divide evenly into 2? No. So I add a 0. Can I do that? Yep. Does 3 go into 20?
Yeah.
Yeah. So when I put the decimal here and I add the 0, I got to put a decimal here. How many times does 3 go into 20? What's the closest we can get?
3 times 9.
No, that's too big.
6.
Oh, 6. Very good. So 6 times 3 equals 18. When I subtract 18 from 20, what do you get?
2.
2. Does 3 go into 2? No. So when we do long division, we can keep dropping these zeros in, and that's how the calculators figure out the decimal. But what do you notice?
We're repeating again.
Yeah, we're repeating. So what do you think this is going to do?
Add another 6.
Yeah, this is just going to go on and on and on forever, right? We're going to keep, it's just going to go on forever. So 2/3 is, my brain towards the end of the day, it just gives up. 2/3 is equal to 0.6 repeating. So that's kind of hard. You would have to say something is 66.6% off. I don't know, that would scare me.
Yeah.
So that's why they don't do that. Okay? I'm not quite sure why, but mainly it's because it's a repeating decimal, but also I think the author of this is trying to be a little funny.
So will we be able to use the calculator on this part?
On some parts of it, yeah. So the calculator will be on the test when you can use it. But I'm going to start showing you guys how to do stuff by hand and then use the calculator to double check it. So you kind of need the combo, right? So if this comes up with the calculator, awesome. If it doesn't, then this is how you do it by hand, okay? Generally, the stuff that you can use the calculator on are harder things that you need the calculator for.
Right.
Okay. Let me stop recording here.